That gives you W dotted with V over magnitude of W, and that's the correct length of my vector. Now, I need the vector that moves in the direction of W, but of this length. So therefore, I have to take this and multiply by the unit vector in the direction of W. And so what the formula should be is W dotted with V over the square of W. That's a scalar multiplying the vector W. That should be the formula that's in your book.
Yes.
In the absolute or the magnitude squared
Yeah.
on the bottom.
She said-
Did I not? Yeah, it is.
There you
I just forgot to square them there, yeah. And if the picture looks like this, your W dot V is going to be negative, and that's because you're going in the direction opposite to the W. Okay. 14, V dot W, positive, negative, 0.
go. Negative.
It's negative. You've got to put your vectors tail to tail to see that. This one maybe isn't quite apparent. Maybe that starts to look orthogonal. And that's, I mean, on a test, if asked that, it should be real clear. But when that's obtuse, then it's going to be negative, otherwise 0.
If they were drawn tail to tail and were orthogonal, would it have the right angle degree?
Oh, I mean, I'd have to give it to you in some way.
Because that's what I thought they were actually orthogonal. 'Cause
Well,
it
I mean,
looks
if I did
perpendicular
something like
here.
this on a test and I wasn't clear, that'd be on me. You know, you guys would have a right to complain no matter how I graded it. But just even doing that, I can see that that's close. So, V and W, if their cross product is 0, then
I'm not, gosh. I'll have it
Parallel.
straight
V and W are parallel.
up.
Comment here is that if you were asked to solve xy equals 0, the only way two numbers multiply to give you 0 is if one of them is 0. If you have two vectors and you dot them and you get back 0, is it automatic then that A or B is the 0 vector? And the answer is no. Neither A nor B has to be the 0 vector.
Can you define 0 vector?
Two dimensions.
Straight up.
Yeah. Well, it's just a point.
Yeah.
3 dimensions, just put the other component of 0 in. So this means either A is 0 vector or B is the 0 vector, or A and B are orthogonal.
Why is it a vector if there's no direction?
it's a quirky setup. I mean, it's to keep it consistent. I mean, if I write down, if I'm just looking at 2 dimensions, that's a vector.
It just has a 0 in
Zero.
But I can put zeros as components.
0 in the z direction.
Yeah. And so that works as a vector algebraically. It keeps it consistent. You also look at it like if you have vectors like this acting on an object, maybe the object doesn't move, in which case the net force acting on that object is the 0 vector. So that's a vector that has neither magnitude nor direct, or its magnitude is 0 and it's got no direction.
When we're crossing, is there like an associative property? Like if we have 3 things that we're crossing?
Yes, that will work. And this property, I mean, I haven't even stressed this. I mean, if I say A dot B is 0, what does that mean? That's fine. Say they're orthogonal. Certainly either of these could be true. The other thing though is A cross B equaling the 0 vector. Also, we can't conclude that one of those 2 vectors is 0. So the vector multiplication, whether it's a dot product or a cross product, does not fit that nice model which you rely on so much in algebra. And those of you, have somebody in here taken your linear algebra? Can you get 2 matrices to multiply to get, yeah. And so you'll see that you can have non-zero matrices, and they also can multiply and give you back a 0 matrix. You know? If I multiply 2 functions, and I get back the function that is identically 0, do those 2 functions have to be 0? No. So there's a lot of stuff that just doesn't behave in this way. All kinds of weird little things. Okay?
Did you skip 12?
Yes.
I very well may have. Equation of the plane. At least in my mind, I always derive this. There is a formula in the book if you feel more comfortable memorizing formulas. This is my normal vector. I have a given point in the plane. X, Y, Z is another random point in the plane. And so when I subtract x minus 3, y minus a negative 1, z minus 6, that's a vector which is parallel to the plane. Which means when I dot it with the normal vector, I will get 0. So this is my way of doing it. If you want to work with formula in the book, that's, you know.
This works well.
It's going to give you exactly the same thing. Dotting it out, I get this. I could then multiply, I get 3x plus 5y minus 6z equals some constant, which if you added those numbers up wrong, I'm just going to go looking right here. Try not to take off points if you're doing it correctly.
So we just dot the normal vector with a vector inside the plane.
Yes.
Okay. Set it equal to 0.
set it equal to 0 because if this is in the plane and that's normal, that's what it means to be normal.
Okay.
Okay? Other questions?
You had the question was the cross product, but then you did the dot product up there, I don't get it.
I was commenting, that was an aside.
Oh,
Well, I thought isn't
if there's
the dot product commutated and the cross product anti-commutated?
The cross product that I gave you was -1, 2, 4.
Okay.
And then I said, what's
These are
B
extreme
cross A?
But put it all together.
So it's the negative. And then my comment was that same property is not true for dot product.
Oh, okay.
That's all. And, you know, in little things like this, it is very easy to simply write down a couple vectors and see if you're not sure. Okay? Questions?
Can we do another page of these, or, I know we only have a little bit of time, but that's
Can we do some, like stuff off the quiz, like parameterization?
whatever.
Just
Oh,
do
I
that.
have
Go
got
for
that.
it with parameterization of circles. It seems like it should be so easy.
Everything's easy when you know how to do it.
Yeah.
Everything's hard when you don't. So, let me
I
see.
don't know, a lot of people think.
Parameterize.
But then going back and looking at it, it's like, oops, steps again. Really there?
Mine is.
This is very helpful, thank you very much.
So this is a circle of radius 4.
Full format.
Hmm?
Full.
So, take a look. There's infinitely many possibilities for this first guy. The easiest one that I know of is 4 cosine is x and y is 4 sine. And if you simply let t pick up this angle, pi over 2 to 3 pi over 2 would do it. There are other possibilities. So, you just need to, whatever you're doing, make sure you're getting the right beginning and ending spot. As for parameterizing along a curve, that's pretty easy. Just let x equal t and y be the function, your t roundings whatever the parameters were. So we were looking at this from a point -1 e to the -1 to 3 e to the -9. Picture here, R of 5 is drawn in standard position. R prime is tangential to the curve and points in the direction of motion. How long R prime is, I don't know. There's not enough information here for me to be able to gauge that. But tangential direction, and it's because the motion is this way, pointing in that direction. V plus W, I need to put these two vectors head to tail, and then I draw from the open tail to the open head. That's V plus W. Okay? Assume those two vectors are placed tail to tail. You want to find the angle between them. So I'm just using V dot W is magnitude of V, magnitude of W times cosine of the angle between them, that angle when you put those two vectors.
I want physics with it. I think doing something else.
You
I
can
didn't
go and
get it.
draw your vectors, and
Yeah.
I mean you can do this a nasty kind of way.
Yeah, I did the result, X, Y.
Yeah, I mean you
component
can
for it.
draw one vector like this, and the other vector I guess is down here, and you can use inverse trig to get that angle, and you can get that, and then I guess you just add them together. But
You do Calc3 instead.
this is real easy. Real easy. So theta is inverse cosine. If you leave your answer like that, that's great. I mean, that's fine by me, you don't have to punch it in. Keep in mind, if you do punch stuff in, and if you punch it in wrong, and I don't see what you punched in, I have no way to give part credit. So you want to show your work, indicate the answer, and if you feel obliged to punch in the numbers, then go ahead. But if you should punch them in wrong, this is the first place I'm gonna look to see what you computed. And real frankly, if this is correct, I'm hard pressed to take off points. I mean, this is a classroom. If you were building a bridge for me, I would need to make sure those numbers were correct. But on a test, that's kind of artificial.
Is that the only, that's about the only formula we've used so far?
I don't
The
know.
projection you can do by you just draw it out, and then you don't have to.
Well, is that,
I mean, there's formulas for finding equations of lines, there's formulas for finding equations of planes. I have issues with formulas. My personal issues are, I can't remember them. And I will do far better, and I used to do far better as a student if I understood where the stuff was coming from. I would be much calmer taking a test as opposed to memorizing, where I would be sure I would forget. So, have we used other formulas? I haven't, but, you know, that doesn't mean that you can't. Okay, folks.
come prepared?
Thank you.
So we can feel pretty
Thanks.
confident that what we went over today should get us pretty graded,
I mean, I am never gonna say that.
right?
There's a study guide that had extra problems. I didn't give you everything, and there's
Right.
all the
Square root of 17.
I
Okay.
mean, I'm just throwing.
Study
it
guides
out.
on D2L.
Yeah.
Yes.
For the answers?
There are.
Okay, yeah.
So are there questions that,
There are
From you, or-
questions on
okay.
D2L, there are boxes.
okay, cool.
And for the problems that I've given you, there are.
I'll just complete all the problems that you put up.
Well, but that's not
Yeah, that's.
just an extra drill
Yeah.
on something.
How you feeling? Thank you very much. And
Right now, yeah.
I'm not before you guys see this. I completely plan on it.
Yeah.
I'll tell you tomorrow.
Okay, thank you.
You can have the cosine of the negative number.